Hey guys, in this video we are going to start talking about parent functions and different words that can describe them. So on page 1 of your notebook, the first thing we're going to do is talk about all the different words that can be used to describe functions. Now linear means that it is in a straight line, and nonlinear is the opposite. That means that it is not straight, it is curved in some way. We've talked about what a function is before. If you were looking at a graph, it's something that passes the vertical line test. Continuous means that you can trace the graph with your pencil without ever picking up your pencil. So that's going to be most of your graphs. That means there are no breaks, no holes whatsoever. Discrete, on the other hand, is the opposite of that. That means that they're just points. They are not connected by a line. Increasing means the graph is going up from left to right. Decreasing is the opposite. It's going down from left to right. So if I'm looking at this first graph, these are the types of graphs that we worked with all of first semester. This is linear, and it's also a function. It is continuous. There's no breaks whatsoever. The arrows mean it goes on forever, and I can trace the whole thing without ever picking up my pencil. That means it cannot be discrete. Same thing with nonlinear. You can't be both linear and nonlinear. You can't be both continuous and discrete, and you can't be both increasing and decreasing. This one, as we go from left to right, it is going down. That means this graph is decreasing. This function is the y equals x function, which is linear. The next graph on the chart here is not linear. If you look, it has a curve right here. It curves back down. So that makes this nonlinear. It is still a function, though it passes the vertical line test. It is once again continuous because I could trace the whole thing without ever picking up my pencil. Therefore, it can't be discrete. Now, if you recall from last chapter, if the arrows are pointing down, that means that the graph is decreasing. This is a quadratic. It's the y equals x squared graph. This is what we spent most of this semester working on. And then the final graph on this page is something that we haven't worked too much with. But once again, there is a curve, so this one cannot be linear. It is in fact nonlinear. It does pass the vertical line test, so it is a function. It is continuous because I can trace the whole thing without ever picking up my pencil. And then finally, while it looks like it might be decreasing here and increasing here if you follow the rules for quadratics, this is a little different. Basically, for the majority of the graph, as you go from left to right, the y values are increasing except for this little bitty part here. But that is an increasing graph. And this is the y equals x to the third power graph, which is called a cubic function. We don't work with that too much in Algebra 1. You'll just need to recognize it. You can handle all of the cubic functions when you get to Algebra 2. When you turn the page, you'll see a bunch of different graphs that have to do with parent functions. Now, parent functions are the most basic functions for each of the different types of functions. So y equals x is the basic or the base for linear. Y equals absolute value of x is the basis for absolute value. X squared is the base for all the quadratics, those types of functions. Okay, so the first thing we're going to do is fill out the chart for the parent function. So we're going to give you a value of x and you plug it into the equation to get the value for y. Now, the linear function is real easy. Whatever x is, y is the same. So I am just going to fill out the y value as the same for the x. And then the graph is just -3, -3 is right there. -2, -2, -1, -1, etc. And you just keep going until we plot all the points. And then you should make a nice straight line here with arrows on the end. Now, if we talk about domain and range, thinking back to the last DMR that we did, remember the farthest left that the graph goes is an arrow, so that's -infinity. Less than or equal to x, less than or equal to, and the arrow here tells me right forever, so that's positive infinity. And my range is going to be the same because this arrow means down forever, this arrow means up forever. So I'm going to write the same range. Okay, and that's it for that one. This is called a linear function. The next parent function we're going to focus on is called the absolute value function. We don't focus on this one too much in Algebra 1, but it is important to recognize it. So let's go ahead and do the same x's here. We'll do -3, -2, -1, 0, 1, 2, and 3. And then I'm going to place them or substitute in for x to find what my y would be. Well, when I take the absolute value of a number, it just gives me the distance away from 0. So the absolute value of -3 is +3. The absolute value of -2 is +2. The absolute value of -1 is +1. And then all the rest are going to be the same. 0, 1, 2, 3. Okay? So when I go to graph these points, they should make a nice V shape. So -3, 3 is right here. -2, 2. -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. And as I mentioned, it should be a nice V shape here. Now, once again, we have arrows that go to the left forever and to the right forever. So my domain is -infinity, less than or equal to x, less than or equal to infinity. But both arrows are pointing up. That means it goes up forever, but it doesn't go down forever. It stops right here. So for my range, the smallest y value is 0 right here on the origin. So 0 less than or equal to y, less than or equal to infinity. Okay? Now the thing that I like to say about absolute value graphs is that they make a V shape. And the way I always remember that is value starts with V and the graph looks like a V. All right, the next one should be really familiar to you. We just got done doing these. This is the quadratic function. All right, once again, we're going to use the same numbers. Okay, and we're going to square them. -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And as you know, this is just going to make a nice little U shape. So let's see, -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. And there's my U. And the domain and range is similar to that of the absolute value, in which the domain goes on forever in both directions, but the range does not. This one goes from 0 to infinity. And once again, this is a U shape. That should not be new to you. All right, we've got a few more on the next page. This one is called the square root function. We have not seen this graph before. All right, so I'm going to use numbers that are perfect squares just so that I can easily graph them. So we'll do, let's see, I'll just put 0 in the middle. Actually, not in the middle because I don't want to do any negatives because that would be undefined. So we'll do 0 and then 1, then 4. Then 9. Then 16, 25, and 36. So that'll end up with 0, 1, 2, 3, 4, 5, and 6 for my y's. All right, so 0, 0, 1, 1, then 4, 2, then 9, 3, and that's as far as the graph is going to go because I just ran out of space. This is a nice little curve here, and it's just going to keep going up in that direction. Now notice there's not an arrow on the left-hand side. So that means my domain is going to start at 0, but then go on forever. The range will do the same. Here's the 0. And this arrow, even though it doesn't really look like it, it's also going up, so I'm going to put infinity. All right, the next one is that cubic function I mentioned a little while ago. Okay. And we're going to do this one again. Okay. All right. I'm going to go ahead and use my calculator for this one just to make sure I get all the right numbers. So -3 to the third is -27. -2 to the third is -8. -1, I don't know why I'm putting this one in because it's going to be 1, or -1 rather. 0 to any power is just 0. 1 to the third is 1. 2 to the third is 8. 3 to the third is going to be 27. All right, so let's plug in the one, or plot the ones that we can. -2, -8 is here. -1, 1, -1, 0, 0, 1, 1, 2, 8. So this is going to make that really weird looking curve, just like that. The graph doesn't look like it, but it's really going to the right and up here, and to the left and down over here. So my domain is -infinity to infinity. And my range is actually going to be the same. Okay, and that's it for the cubic function. It's going up here. You can also have one that starts up and ends up down here. That would be a negative or a decreasing cubic function. All right, the last one we're going to talk about is an exponential. In this case, 2 to the x is going to be what we're dealing with here. So let's just do the same thing. Okay. So 2 to the -3rd is an 1/8, which is the same as 0.125. 2 to the -2nd is 0.25. 2 to the -1st is a 1/2. Anything to the 0 power is 1. 2 to the 1st is 2. 2 to the 2nd is 4. 2 to the 3rd is 8. Okay, so let's do the whole numbers that we know we can easily plot. We have 0, 1, 1, 2, 2, 4, 3, 8. And then you should notice that as we go into the negatives, it starts to flatten out. So let's see, a 1/2 is about there, a 1/4. So the exponential graphs get really, really close to 0, or to the axis rather, but never really touch it. So be careful that you don't actually touch or cross the x-axis. Once again, there are arrows on both ends signifying it goes left and right forever. So I have -infinity to infinity for my domain and also for my range. Okay, never actually crosses we call that an asymptote. I feel like there's a y in there somewhere. In this case, that asymptote is the x-axis. It is possible for it to be below the x-axis, and then you would touch and cross the x-axis, but for the purpose of this class, we're just going to focus on the asymptote being at or near the axis. So when you're doing these types of problems, you're not going to be required to graph each of these at the beginning. I just want you to be able to recognize them. Eventually, we'll talk more about exponentials in this chapter, and you'll learn how to graph each one.